So we're going to start here with our inputs on the transmit side. This is our microphone, which is powered by about 5 volts DC. So we have a voltage divider over here that takes our 9 volts coming in and it sends 5 volts to the microphone. We modulate that just by speaking or putting a microphone up to it. That signal then goes to the capacitor here, which filters out the DC. So we only want the modulated signal. We don't want the 5 volts. From our capacitor, we have our resistor here that helps control the gain in the op amp. And from here to pin 2 in the op amp. Also, we have another input. This yellow wire here leads to this. Let's hook up to a cell phone, iPod, whatever. It runs across into here. Because cell phones put out a pretty good signal themselves, we have a voltage divider here as well, which cuts it in half. Then we run that through a capacitor to filter out any DC that might be there, although there shouldn't be any. And then we have another gain resistor here, which helps to control the gain. And from here, it also goes to the input of the op amp.
So we're using our op amp as a adding circuit, so it adds both the audio input from the audio cable and the microphone together. So to do that, we loop them all to the same input pin. We then take the op amp and add some gain to it through this resistor. This resistor ratio is a 10K resistor. On our speaker we have a 10 ohm resistor, and on our audio input we have a 100 ohm resistor. We need a larger gain across the microphone just because the signal from the mic is so much weaker. So then we take our output from pin 6 and it feeds down into our bias T. Our bias T is composed of a capacitor, inductor, and a resistor, in this case a potentiometer. We adjusted our potentiometer to take a 4 volt signal to our laser. This is so that the laser is always on when it's trained. We have only one power source. We needed a way to take that one power source to power this op amp. Typically you have the op amp with a +9 and a -9 side to it. However, in our case we have a +9 and a ground. And to not lose any of the signal coming in from our input, we needed to bias our op amp up so that the new center line of our signal was at approximately 4.5 volts. So we had to feed it through this set of resistors, which is acting as a voltage divider. And it's from here that it gets its the voltage that it requires, so to bias our new signal.
Comes in through our solar panel, which then passes through this capacitor, which is used to reduce the noise. We have a 10 microfarad capacitor here to maximize the gain. The signal then, the amplified signal then passes through our, what we have here, frequency filter, high frequency filter, and then the remaining signal goes through this large capacitor, which goes through a speaker to power it.
Yeah. That's to the mic, right?